teens. How are you? I hope you're doing good today. Most of you just come from school. I'm in studio. My name is Deborah Precious. I'm in studio today with Tamlin, and she will be doing analytical geometry in mathematics today. And we have a very special guest in studio today, and his name is Edzai. Now, this man is so passionate about maths that he decided to write a book about it. So, Edzai, tell us what's going on in your book.
Good day, everybody. My name is Edzai Jobo, and as Tebogo has mentioned, I'm a mathematician by profession, and I'm here to talk about the book that I wrote. It's entitled The Mathematical Genius in You, and it's a motivational book to teach you how to think like a mathematician, to teach you how to succeed in maths. So when I was teaching, I discovered that quite a lot of people fail maths, not because they don't have the ability to pass maths, but it's because they lack in self-confidence.
Yeah, that's
so
true.
This book is there to boost your confidence and tell you that maths can. So today I say I'm an evangelist of maths because I have come with the good news to say that it can be done. Everybody can do maths.
Wow, that is amazing, guys. I'm sure you guys would love to have this book with you. I know I would, and I wish I did, and back in high school. And we're going to post a few questions, a few challenge questions, and 3 of you will stand a chance to win this amazing book and keep with you. So get ready, just check our Facebook page, see if you can answer the mathematical questions. I'm sure most of you will be able to. And go ahead, the book is up for grabs, guys. Now, I think we should quickly go to a break. And we'll be back just after the show.
Sure.
Welcome back to Mindset, guys, the home of the brain. Tamlin, could you let us know what to expect in today's show?
Right, well, today, firstly, welcome grade 10s. Great to see you all again. Last week, we introduced the basic concepts of analytical geometry and really just giving everybody the building blocks as to what the section is all about. So today, we're applying all of that and making everybody think a little bit today. So last week was kind of the beginning part of it. Today we're going to really make everyone's brains work.
Well, I hope you guys are attentive, comfortable, and ready to take on the lesson. I'll be waiting here for your posts, your questions, your comments about today's show, and enjoy the lesson, guys.
Thank you. Right. So, grade 10s, as I mentioned, we started off last week by giving you really sort of the building blocks and the introduction to what analytical geometry is all about. So, it's not all very well to know that. We need to know how to apply it, okay? And that's what we're going to be doing today. So, let's quickly have a look just at our lesson outline and what we can expect to be doing today. Just in terms of what we learned last week, we learned about the distance formula. Today, we are going to be applying it, okay? We're going to be applying our midpoint formula, the gradients of a line. Remember last lesson we spoke about lines that are parallel, and if you recall, just quickly, parallel lines had the same gradients, and we have perpendicular lines where the gradients meet each other at a 90-degree angle, and that the product of the 2 gradients will always equal -1. If you don't remember, we'll go over that a little bit later. And finally, what we're going to do is throw all of these concepts together into one example and actually apply them all together at once, okay? Just to give you a quick refresher in terms of the formulas, your distance formula, just remember, you've got your distance from point A to point B, which would be AB squared, which is equal to your x1 minus your x2 squared, plus your y1 minus your y2 squared. Please become very familiar with that, guys. That's a very important formula to know. Then you've got your midpoint formula. Midpoint formula, we've got our x, the first x value plus the second x value divided by 2. That gives us the x coordinate of the midpoint. And ya plus yb divided by 2 will give us the y coordinate of your midpoint. Okay. And finally, if we remember from last week, we discussed the concept of gradient and sort of visualizing it as climbing a set of stairs and how we took a step up and a step across. And as we got up that set of stairs, so we actually climbed the slope. And the slope essentially then was the change in y over the change in x. Okay. So with all of that said and all of that remembered, what we're now going to do is, first of all, get you guys thinking a little bit. I'm going to give a quick challenge question to you. I'm not going to answer it now. I want you guys to spend some time thinking about it, and I'm going to answer it a little bit later. But this is the question. Sorry, we're jumping backwards there. Here's the question. Okay, let's read it together quickly. I want you to write it down, and I want you to think about it, okay? And in the time that we go on our ad breaks, I really want you guys to go and think about it and try this question. What we have got here is point A, which is negative 2 and 5, point B, which is negative 4 and negative 2, point C, which is 3 and A, and point D, which is B and 3. And these are 4 points on the Cartesian plane. So what they're asking us to do here is to determine the value of the A, here's the A, and the value of the B, which is over there, such that, now here's the important information, so you've got to read this carefully. What they're saying to us over here is that line AB is parallel to CD. So your line AB is parallel to CD, and your line AD is perpendicular to CD. Okay. So I'm going to give you a small push along in the right direction over here just to send you on the right track. And this is how you need to be interpreting this, grade 10s. If you've been told that two lines are parallel, okay, as I mentioned it a few seconds ago, parallel lines share the same gradient, okay? So to now take that information, actually start working with that as a sum, we're going to take the gradient of your line AB, and you will make it equal to the gradient of your line CD. I hope that makes sense to you guys. And then we've been told that AD is perpendicular to CD. Okay, so what did we learn last week about that? The gradient of AD times by the gradient of CD has got to equal negative 1. Remember, they're the inverse of each other with the opposite sign. Right, so there we go. I've given you a bit of a push in the right direction. That's what I want you to please go and think about and give a try to. But in the meantime, let's start with some other examples, and you can give that a try in our break. Okay. Right, let's get going with this question over here. They've said that in a triangle with vertices A, which is negative 1 and 7, B, which is 8 and 4, C, which is 5 and negative 5, is given. And they want us to show that we should have a little copy there for our angle. Show that ABC is 90 degrees. So in other words, show that the angle B is 90 degrees. Okay. Right, let's see. How would I go about doing this? I'm wanting to prove if something's 90 degrees, I'm wanting to prove that it is perpendicular. All right? So essentially what I want to do is I want to prove that the line AB is perpendicular to the line BC. Okay. So let's see if we can go about doing that. Well, let's see if we land up with perpendicular gradients. So let's start with the gradient from A to B. Gradient, remember, is your change in y, so y1 minus y2 over x1 minus x2. And let's see what we've got here. Gradient from A to B. I'm going to call that x1 and y1, and this I'm going to call x2 and y2. Remember last week I labeled them a lot because it's just easy to make a silly, silly mistake with regards to substitution. So just label them. It avoids anything unnecessary mistakes. Okay, so y1, which I've labeled as 7, minus y2, which I've labeled as 4, over x1, which is negative 1, minus x2, which is 8. Okay, that's going to give us 7 minus 4, which is 3, and 8, negative 1 minus 8 is negative 9, and we can simplify that to a third. Okay, so we know that the gradient from A to B is a third. Let's see what the gradient from B to C is going to give us. I hope in your head you already know what the answer we're looking for should be, but let's see if we can confirm that for you. Okay, what I'm going to do is take that out, and let's do it in a different color to not confuse anybody. So let's now call that x1 and y1 and x2, y2. Okay, so y1 minus y2. Watch out for the double negative there. It becomes positive. Over x1 minus x2. So I've got a 9 over, how am I right there? y1 minus y2 over x1. Sorry, there's an 8. 8 minus 5, which is 3. And 9 divided by 3 is 3. So how do I know from that gradient and that gradient, how do I know that they are perpendicular? Well, if I take the two gradients and multiply them together, so in other words, if I took a third and I multiplied it by 3 over 1, what do we land up with? Negative 3 over positive 3 is the same as negative 1. So remember, guys, that's how we prove that the lines are perpendicular. So therefore, what is our conclusion? We're going to state that therefore, angle B is equal to 90 degrees. We've proven it's perpendicular. Okay, right. What's the next thing they're asking us? Same diagram, same coordinate points. This time what they're asking us to do is to prove that triangle ABC is isosceles. Okay. Now, guys, probably a very good idea with analytical geometry is draw yourself a picture of what the diagram is doing. Okay. Often it takes just random points and it actually makes sense of what's going on there. So let's quickly do that. Let's draw ourselves a Cartesian plane, and I'm going to more or less plot the points. They're not going to be 100% exact, but we'll get more or less there. Negative 1 and 7. Okay, so my point A, I'm estimating is about there. I've got 8 and 4. Let's estimate that's going to be about there. So there's point B. And positive 5, we'll probably put about there, and negative 5 about there. Okay, so there's my point C, roughly. Okay, and they're wanting us to prove that this is an isosceles triangle. So let's join our points. I've got from A to B to C. There we go. All right. Okay, so how would I go about proving it's isosceles? Well, do you remember one of the things we learned last week is that we've got a distance formula, all right? Now, what is an isosceles triangle? It's a triangle that has got two equal sides, okay? Two sides are equal in length. So the idea here is to apply our distance formula and to prove that two of the lines are actually equal in length. So let's see what we can do. Let's start with our lengths from A to B. So let's do it over here. Okay, so my distance from A to B squared is equal to x1, y1, x2, y2. Right, so negative 1 plus, no, that's minus 8, sorry. Minus 8, and remember that that has to be squared, plus 7 minus 4, and that has to be squared. That's going to give me a negative 9. That is going to give me a 4, 5, 6, 7. That's a 3. Okay, so we've got 81, and I have got 9. And if I put that together, that's 90. But please don't forget that it's AB squared. So to get the distance from A to B, we must square root it, and we're going to leave it in third form. So the distance from A to B is the root of 90. Okay, so that's what we've got for now. Let's now take the next side. Let's take BC. So the distance from B to C. All right, so let's just take this out so we can write our new values in. I've got x1 and y1, x2, y2. Okay. So x1 is 8 minus x2, which is 5, plus y1, which is 4, minus negative 5, which is going to be plus 5 squared. That is giving me 8 minus 5, which is actually 3. I'm getting a 9 plus 4 plus 5, which is a 9. This is looking pretty familiar. I've got a 9, and I have got an 81, which again is giving me 90. Okay? Just again, bear in mind that we had a BC squared. BC squared. So to get rid of the squared, we obviously square root it. Okay, so that's great. I've actually proven that those two sides are equal in length, that they both are equal to 90. So that's fantastic. I've got two sides that are equal. What you do need to do, however, is prove that the third side is also not a root of 90, okay? Just to make sure that it's obviously not an equilateral triangle. So prove that two of your sides are equal, that one of the sides is not equal. I'm not going to do that now because it doesn't work out as equal. I'll let you know. And you do land up proving that it is isosceles. Okay, so there we go. That's using distance formula to prove an isosceles triangle. Okay. Right, a new question. Let's see what we've got over here. Okay. Points A, which is 2 and 8, B, which is 8 and negative 1, and C, which is 4 and A, lie on the Cartesian plane. Okay, so that's a pretty standard start. Everything kind of looks like it would normally. And then they've asked me to find the value of A if, okay, now here's the important part, if A, B, and C are collinear. Okay, collinear is a word we might not have actually worked with yet, so let's talk about that quickly. If points are collinear, they are points that are sitting on the same line, okay? So if I've got points that are sitting on the same line, so let's just quickly do this as an example. Give ourselves. Let's call that point A, and let's call that point B, and let's call that point C. For me to get from point A to point B, I would have to go up a, oh, no, we went back to black there. We would have to go up a certain amount of units and across a certain amount of units. And we'd have to go up and across. So I'm actually missing those a little bit over there. But anyway, the point is to illustrate that they share the same gradients. Okay, so the gradient from point A to point B would be the same as the gradient from point B to point C, and that's what we're talking about as far as collinear goes. They're points that are sitting on the same line, and the gradients is equal. So therefore, how do we apply the knowledge? We therefore know that the gradients from point A to point B is equal to the gradient from point B to point C. Okay, so let's now put that into practice. So y1 minus y2 over x1 minus x2 is equal to y1 minus y2 over x1 minus x2. Obviously, we're working with the two different sides though. Okay, so from A to B, I'm going to say that 8 minus negative 1, which is a plus 1, over 2 minus 8 is equal to, now we take y1 from the B point, so negative 1 minus a over 8 minus 4. Okay, right, so obviously what we land up with is an equation that we can solve. All right, so let's see. 8 and 1 is 9. I'm left with negative 6 down below. I've got a negative 1 minus a, and I have got 4. All right, let's cross multiply. I'm going to bring 4 up to this side over here, so that gives us 9 times 4, which is 36. And I'm going to multiply negative 6 up on the other side over here. All right, is that fine? So we've got 36, which is equal to 6 plus 6a. All right, if I bring my 6 over, that's going to land up giving me 42. No, it's minus. Whoopsie, sorry. We're going to subtract it. Okay, so sorry, 36 minus 6, which is going to give us 30, which is equal to 6a. And obviously, we're going to divide by 6, which is going to leave us with 5. So there we go. So we used collinear. So the fact that they told me it was collinear was your clue in terms of what you actually had to do with it. Okay, so guys, please remember that collinear means you have the same gradient, and you apply the theory that you make the one gradient equal to the other gradient. That's how you would work with collinear points. Okay, right. Hope you're understanding all of that so far.
I think it's now time for a break.
Oh, am I making you work too hard already?
Sure, time flies. Hey,
right,
we're already done with our first section of the show. But stay tuned, because we'll see you guys after the break. Sorry. Welcome back, grade 10s. To those of you who've just joined us, don't worry, you haven't missed much, because the notes are available on our Facebook page. Make sure you do check that out. Oh, and also pay attention to our challenge questions. I'm sure some of you, someone out there, might get it right. Tamlin, over to you.
Well, before we carry on, I'm quite interested to know how anyone's doing in that challenge question.
There are a lot of answers, but doesn't seem like any of them are getting it correct.
Not quite getting
You
it
might
right
want to
yet.
give them another hint.
Okay, I'll give them a small hint, just a small one. If we've got our Pascal's triangle, which is what we've got over here, I've got my 3, I've got my 3 and my 1. I want you to consider if I had this, if I had an a plus b squared, okay, looking at the pattern that we land up, if I square that out, I would land up with an a squared from squaring my first 2 terms. If I multiply my first 2 terms and double it, I get a 2ab. And then if I square the last term, I get a b squared. All right? So write that down, grade 10s, and I want you to see if you can now actually consider or pick up some kind of pattern in terms of that over there. All right. Okay, so that's a small hint for you. Now I want you to please carry on with me with our analytical geometry. Okay. We've got a nice diagram over here. This is quite typical grade 10s in terms of what you would receive in terms of a test question. So definitely get used to this kind of thing. Okay, so they've given us a diagram. It's obviously a quadrilateral, which we can see. And they've given us our points A, B, C, and D. And in this case, I can actually see they've given me all the coordinate points. There's nothing there that's missing, which is quite nice. Okay, so the first thing they're wanting us to do is to determine the gradient of the diagonals. Okay, so we're going to actually draw in a line here. The diagonal from A to C and from B to D. Okay. Right, so let's work out what the gradients of those would be. So my gradient from A to C is going to be, I'm going to call that x1 and y1, x2 and y2. Okay. y1 minus y2 over x1 minus x2, and I'm landing up with a 7 over a 7, and I'm getting a gradient of 1. Okay? All right, so that's the gradient from my diagonal A to C. My diagonal B to D, let's see what we've got over there. Let's call this, let's do it in a different color so we don't mix it up. So let's call that x1, y1, x2, y2. Okay, so therefore we have got 3 minus negative 4 over negative 3 minus 4. So we're going to land up with a positive 7 over a negative 7, which is negative 1. Okay, so what can we see from that, grade 10s? We've landed up with a gradient of positive 1 and a gradient of negative 1. Looking at that, that should immediately tell me that I have got a perpendicular, I've got perpendicular lines over there. So there we go, those are actually intersecting at a 90-degree angle. Right, the next question following up from that. Are the diagonals of the quadrilateral perpendicular? Well, yes, because we've actually just proven that. So we had the 2 diagonals, and we proved that they were actually at a 90-degree angle. They intersected at a 90-degree angle. Give a reason for your answer. The reason, the way we would go about doing that is we would do this. Let's just give ourselves some space here. The gradient from A to C times by the gradient from B to D was actually equal to negative 1. And therefore, the lines are perpendicular. Okay. Perpendicular. All right, so that's just proving that's a statement that's being made just to prove that the 2 lines are actually perpendicular. All right, following on from that, still the same question, just following on. They're now asking us to determine if the origin lies on the line BD. Okay, so let's see. My line BD is obviously this diagonal over here, and they're wanting us to determine if the origin actually does lie on that line, okay? How would we go about doing that? Okay, well, the first thing I would say to you is that, well, the origin is the coordinates of what? Okay, it is the coordinates of 0 and 0, okay? So we're trying to establish that this pink line, just bear in mind that the diagrams are not always to scale, so just watch out for that. But we're trying to prove that, in fact, it would actually pass through the origin. Let's find the equation of line BD. All right, we've already proven in the previous question that the gradients of that line was negative 1. So therefore, let's do this. The equation of a straight line graph is y equals ax plus q, where remember the a is your gradient, which we've already proven is -1. So that work has already been done for us. And to work out what the y-intercept is, what I can do is take either point B or I can take point D, it really doesn't matter which one, and substitute it into the x and the y. So I'm going to take point B just because, and I'm going to substitute y with +3, and I'm going to substitute x with -3. Okay, what does that give us? It gives me a 3 equals 3 plus q, and when I bring it over, I land up with 0 being equal to q. So what's the equation of the line BD? Y is equal to -1x plus 0, okay? Well, that's telling me then that I've got a y-intercept of 0, all right? And if it's got a y-intercept of 0, it in fact absolutely is passing through the origin. It has to be, all right? So therefore, proven. We've proven that the line will be passing through the origin, okay? Another way we could just go about doing it, just in case you're interested, is that what we could do is take the coordinates of your origin, which is the point 0, 0, and substitute it into the equation of the line BD. We can actually plug in x and a y with 0 and 0. And the point of that is that if we get to prove that the left-hand side equals the right-hand side, you are proving that it's true and it actually does sit on that line. So it's just another way of proving it, okay? Okie dokes, let's see what else we need to do here. Okay, still the same diagram. Now what they're asking me to do is determine the coordinates of the midpoint of the diagonal AC. Right, so let's just quickly draw those in again. So we had the diagonal from A to C and the diagonal from B to D. Proving that the coordinates of the midpoints of AC, okay, so basically what we're looking for is the halfway mark from A to C and B to D. So therefore, midpoint. The midpoint from A to C is going to be as follows. I'm going to take x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay? That's going to give us a half over here, and I'm going to get negative 1/2. So I've got positive a half and negative a half as the x and the y coordinates of the midpoint from my line A to C. Okay? Right, then I'm looking for the coordinates of BD, the midpoint from B to D. Okay. Okay, let's see. So from B to D, I'm going to have a -3. Oh, is that so? I think I just have done BD, actually. Oh, sorry, guys. I think I got my coordinates a bit mixed up there. I'll tell you what. What we want you to... Okay, you guys can actually work that out quickly. That's not going to be too difficult for me. Work them out. If I'm not mistaken, we had a -1/2. Just quickly check your numbers. The midpoint for this one over here should be -3/2 and +3/2. And the midpoint for this one over here should be around about, if I'm not mistaken, it's +1/2, -1/2. Okay. All right, so that should be what the coordinates of your midpoint are. Just getting your numbers right there. Okay. What we want to do, however, with that is that they want to ask you, do the diagonals bisect each other, okay? Now, the whole point of the previous example is we worked out the midpoint of the one and we worked out the midpoint of the other. And by doing that, we should quite clearly see that we have two different midpoints, okay? That implies that the diagonals do not bisect each other. Because if they did, they would cross each other at exactly the same midpoint. So therefore, the answer to this, no, they don't bisect each other. Why? Because they don't share the same midpoint. Okay. All right. So what does that lead us to then? So the answer, now what they're asking us to do is to calculate the lengths of the sides A, B, and BC. All right, sides A, B, and BC. A to B and B to C. Okay. Let's just quickly draw in those diagonals again. So drawing that diagonal over there and this diagonal over here. Okay. Right. let's work out the distance from A to B. My distance from A to B is going to be x1 minus x2 squared plus y1 minus y2 squared. So we're getting a 5 squared plus a 5 minus 3, which is going to be a 2 squared. So we're getting a 25 plus 4. So we're getting the root of 29 as my distance from A to B. All right? My distance from B to C, I'm getting an x1 minus x2 plus y1, which is a 3 minus y2, which is going to be squared. I'm getting, that's going to be again be 2 squared, and in fact I'm getting a 5 squared again. So we actually are landing up with the length from B to C as also a root of 29. Okay, so we've got root 29 and root 29. Okay, so with all the information that we've actually discovered about this diagram so far, they should start becoming clear as to what kind of quadrilateral. Remember we had a 90 degree over there. The diagonals didn't bisect. Okay, that was an important one to remember. So finally, the last question that's being asked here is, what kind of quadrilateral is ABCD? Okay, well, let's go back just to the previous diagram and look again. We had adjacent sides that were equal in length. We had diagonals that didn't bisect each other but did intersect at a 90 degree angle. What type of quadrilateral do we have? I hope at this stage you guys are all telling me it's a kite. Okay, we've got a kite as the quadrilateral that we are working with over here. And basically the idea would be, guys, in terms of analytical geometry, I'm sure in class you guys have all just, recently finished your quadrilateral section where you've worked a lot with parallelograms and rhombuses and kites. And analytical geometry actually ties in quite a lot with that, because what we now do is use analytical geometry to prove all of those quadrilaterals. So using analytical methods, we've proven that we had a 90 degree intersection of the lines. We proved that the adjacent sides were equal in length. We proved that the lines did not bisect each other. So therefore that proved that what we had was actually a kite. Okay. Right. And that was the final question there. Right, now they've thrown one last little question in here just to throw us off the path just a little bit over here. So what they've said is this. If A, B, C, and then we've thrown in a new point here, which is point E, is a parallelogram. Okay, so let's highlight what we've got over here. I've got point A, B, C, and then we've got a new point E. Okay, now first of all, we don't know where that point E is. We're going to have to, at this point, take a bit of a guess as to where it would be. But what I do know is that it needs to look like a parallelogram. So it needs to do something like this and like that, and it would take the shape of a parallelogram. Okay. Do I know what the coordinates of E are? I most certainly do not. I have no idea what the coordinates of E are. Okay, well, at least I haven't proved them at this point. So what we need to do is find the coordinates of E. This is a very common question, a very liked question amongst teachers. So just listen carefully with this one. Find the coordinates of E, all right? Take note of the fact that we've been told it is a parallelogram. Now, one of the properties of a parallelogram, guys, is that the diagonals of a parallelogram do bisect each other, which means this, that the line from D to E and the line from A to C, where they intersect each other, they would share a common midpoint. Okay? So, would we be able to find the coordinates of that midpoint? Well, we could, because I do know the coordinates of A and I do know the coordinates of C. So let's start there. Let's find what the coordinates of your midpoint are going to be. So I'm just going to call the midpoint M, all right? And M is going to be x1, which is 2, plus x2, which is negative 5, divided by 2, and y1, which is 5, plus y2, which is negative 2, divided by 2. And if I simplify that, we land up with negative 3 over 2, and we had positive 5 minus 2, which is positive 3 over 2. Okay. All right, so therefore that's the midpoint. I'm just going to draw an arrow just so it doesn't look untidy. And that gives me negative 3 over 2 and positive 3 over 2. Right, so why is that useful to me? Why do I need to know that? Because I'm going to now use that midpoint to help me find the missing coordinates over there. Why? Because we know that this point over there is actually the midpoint not only of AC, but also of BE. So let's quickly finish that off over here. So to find the midpoint, so the midpoint from B to E, I'm going to take x1 plus x2. So we're going to take negative 3 plus x divided by 2. But what we know is that it's equal to the x midpoint. And can you see how we're going to solve for x there? Okay, so we're going to land up with 2 being multiplied by negative 3 plus x, and 2 times 3 is negative 6. So therefore negative 6 plus 2x is equal to negative 6. I'm going to land up with 2x, which is equal to 6 minus 6, which is 0. So I'm getting a 0 coordinate for my x. And let's quickly get my y coordinate. We're going to take y1 plus y2 divided by 2. So 3 plus y divided by 2. And that was equal to the y midpoint, which was positive 3 over 2. And very quickly, let's work that out. So I'm going to take 2, which is multiplied by 3 plus y, which is equal to 6. 6 plus 2y, which is equal to 6. And in fact, we land up with the same thing. It lands up being 0 over there. So what is the point of E? It's the point of 0 and 0, which in fact, if we look at my diagram, was very much where we actually had it. So that's how we would find the missing coordinates of a parallelogram. Right, guys, I hope you're all working on that challenge. We're going to have a short break, and then when we come back, we're going to have a look at it, okay?
Yes. With better understanding comes improved marks and confidence. So make sure you understand on what is being taught. See you guys now. Welcome back, grade 10s. Just a reminder to download your notes from our Facebook page and post your questions and comments there too. Over to you, Tamlin.
Thank you. Right, guys, so at the very beginning of the lesson, I gave you a question that I wanted you to have a look at. And it was a fairly tricky question, and if you've actually given it a chance or if you've had a look at it, you'll probably understand why, in that we actually had to apply a little bit of algebraic knowledge here in the form of a simultaneous equation. So let's put it together and let's see how we do with this. What they said was we had point A, which is negative 2 and 5, B, negative 4, negative 2. Then I had at point C where I had a variable. I had point 3 and A, and D, which was B and 3. And they are all points on your Cartesian plane. Okay, right, so that's done. They asked us to find the values of A and of B and they gave us 2 important pieces of information over here. They said that AB is parallel to CD. So AB is parallel to CD. And AD is perpendicular to CD. Okay, so we had to use those 2 pieces of information to put together this whole sum, all right? So by now, I'm sure you guys are getting the hang of it, that when we're talking about parallel lines, we have to start with gradients, and obviously they are equal to each other. So we're going to take the gradient of AB, and I'm going to make it equal to the gradient of CD. All right, so I'm going to be very careful with my working out here because I don't want to go and make any silly mistakes. So point A is that, point B is negative 4, negative 2. And we're going to call it x1 and y1, x2, y2. Okay, so the gradient from A to B is equal to the gradient from C to D, so therefore I have got y1 minus y2 over x1 minus x2. That's going to be equal to the gradient from C to D. C, I've got x1, y1, x2, y2. So that's going to be A minus 3 over, and I've got 3 minus b. Okay, so it looks a little bit odd at the moment, obviously, because we've got variables in it, okay? So let's cross multiply. I'm going to land up, I've got 7, and I have got 2. I've got a minus 3 and 3 minus b. If I multiply 7 by 3 minus b and 2 by a minus 3, let's just tidy that up. 21 minus 7b is equal to, I've got 2a minus 6. Let's bring this over. Let's bring 21. It's going to be 27 minus 7b is equal to 2a. Okay, so at this point, the clue that it would be involving simultaneous equations is the fact that we're sitting with two different variables inside a sum. Okay, so there's kind of, it's leading us in the direction of your simultaneous equation. Let's use the other piece of information now. They said that AD is perpendicular to CD. Okay, so remember with that, the gradient from A to D times by the gradient from C to D has to equal -1. Okay, so AD, my gradient from A to D, y1 minus y2 over x1 minus x2 times by my gradient from C to D, which is going to be y1 C to D minus y2 over x1 minus x2, and remember that that had to equal -1. Okay, let's tidy up. 5 minus 3 is 2. I've got -2 minus b times by a minus 3, and I've got 3 minus b equals -1. All right, guys, so this is just a case of just careful working out. Let's just multiply. So that 2 is getting multiplied by the a minus 3, and -2 minus b is getting multiplied by 3 minus b, and it gives us -1. Okay, let's distribute and let's FOIL out. I've got 2a minus 6. I have got, when I do my firsts, I'm going to land up with -6. I'm going to get -2 minus b, which is plus 2b. I'm going to get -3b, and I'm going to get positive b squared equals -1, okay? Right, so we're not done. We're going to just tidy up a little bit more. 2a minus 6 is, in fact, no, I'm not going to put it over at this point. I'm going to multiply it off onto the other side. So is equal to, now if I multiply all of this by -1, what's going to happen is that all the signs are going to change. So it's going to land up with positive 6. If I just quickly added like terms, plus 2 minus 3 is -1, and if I then change the sign, it will become plus 1b and minus b squared. Right, sure, lots of working out here. So 2a is equal to, what I'm going to do is, in fact, no, let's rearrange it this way. Let's bring b squared over, because remember, if you've got a b squared, the kind of equation we're working with here is quadratic equations, okay? So b squared comes over to be positive b squared. I've got plus 1b. I've got minus 6, and I've got a plus 2a. And I've got a minus 12 equals 0, okay? So at this stage, what do? I've got these two equations. I've got a's and b's all over the place. How do I simplify this? That over there is a 2a, all right? And 2a, we're saying, is equal to 27 minus 7b. So a method of simultaneous equations we can use here is to substitute. Can you see that there's a 2a in that equation over there? I hope you spotted that. So we're going to substitute it. So we're going to say b squared plus b plus, but now instead of 2a, I'm using the 27 minus 7b minus 12 equals 0. And let's simplify that. So b squared minus 6, that's going to be 6b, and I've got 27 minus 10 is 17, 16, 15. So I've got 15. Okay, somewhere along the line I have made an error that we should actually have an 8. So obviously I've made a mistake somewhere. That should be a minus. So just check you're working out against mine. That should be a minus over there. All right, and when we factorize it, because remember that's what we do with the quadratic equation, we factorize. Shouldn't be squared. We land up with a b and a b. Factors of 15 is 5 and 3, both of which are negative. So we landed up with b, which was equal to 5, and b, which was equal to 3. I really hope you guys got those values for b. However, just bear in mind, you're not actually completely finished that just yet. You need to then actually substitute it back into the equation. So once you've worked out what the two values for b are, 27 minus 2b minus 2b was equal to 2a. That was the first equation. Minus 7b, sorry. 7b. Okay, so what I now need to do is just substitute back. So 27 minus 7 times 5 equals 2a. So I've got 27 minus 7 times 5 is 35 equals 2a. So that's going to give us negative 8 is equal to 2a. Negative 4 is my first answer for a over there. And if I substitute the other value in, 27 minus 7 times 3 equals 2a. 27 minus 21 equals 2a. 27 minus 21, that's leaving us with 6. And so obviously 3 is equal to your a. All right, guys, so that was the challenge. It was lots of working out there, but I really hope you guys got a feel for it and to understand that you can actually get simultaneous equations in analytical as well. So there we go. Lots of hard work from today.
Thank you so much, Tamlin, for the great lesson. I'm sure it was refreshing and they have benefited from it.
Fantastic.
Remember, guys, if you develop a positive mental attitude towards maths, you will excel. You cannot go wrong. Don't forget to practice all the way. Until next time, goodbye.